Hi folks. Over the next two videos, I'm going to be assigning meaning to edits. I'm going to be writing functions that interpret edits with the general goal of taking some input strand and a list of edits and then producing an output strand. So we're going to do this over two videos. In this video, we'll talk about this function that works on a single edit. In the next video, we'll talk about this function that takes a strand and a list of edits and produces another strand. At the end of the day, this is the function we'll be most interested in, but the real heart of the matter, the real meat of the work is happening above. So just to briefly talk about this function's type, just so we know what we're building up to, the idea is we take in an input strand, we take in a list of edits, and we're going to output the output strand, a new target strand. So that input strand we're calling our original strand or our source strand, and the goal is to produce an output or target strand. So along the way, the core engine here, the real logic of how we're understanding edits is this function. This is the function that says you give me a single edit and an input strand, and then I'll tell you what it means. What does it mean? So in your file, this type is written this way. It just says option base star strand. And that's what we'll return. Why is that the return type? Well, I'd interpret it this way. First, this is the way that it's implicitly parenthesized, right? It looks something like that. Next, it's telling the other function sort of what to do. Here, this part of the type is saying, do I need to write anything to the output strand? Right? It'll be none if we don't write anything to the output strand from this edit, and it'll be some if we do have some base to add to the output strand. Okay, now this strand, this is what's left of the original strand. So that's what we'll be returning each time. Here's anything that needs to be written for the output strand, and then here's what's left of the original strand. And different edits do different things, and as we get through the function, you'll see why we need all of these parts. So looking at it, it's probably a little bit intimidating. This is a bunch of nested matches. This is a bunch of logic. Let's go through slowly. I'm not going to go through top to bottom. I'm going to go through in the order that I think is easiest to understand. Let's start with add. This is certainly the shortest line, right? It's just one thing. Add always does the same thing. So if the edit add B means write the base B onto the output strand. It's like, oh, okay, cool. Not so complicated. So what does that mean? Well, then what will we return? Well, we'll return some B. We'd like to write B to the output strand. And then add doesn't do anything to the original strand. We haven't looked at it at all. We haven't consumed any bases from it to copy them or whatever. They're just there. So what this line says is we need to add B to the output strand, and then we still have the original strand as is. The next edits will work on the original strand. The way to think about this is that we sort of have a cursor, and if here's the original strand, we have a cursor into it. When you get to an add edit, the cursor just stays where it is. In other edits, maybe it'll advance by a base. Okay, speaking of which, let's look at substitute. Substitute is, I think, the next simplest. So substitute B says, look, whatever base is already there in the original strand, I don't want it. I want you to write the base B instead. How do we implement that? Well, we say, look, we definitely need to output the base B. No matter what was in the original strand, we need to write B to the output strand. Okay, what's left of the original strand? Well, that actually kind of depends. So this is the case that we really care about. Like, really, substitute should only happen when the original strand had a base there. Otherwise, it's weird to talk about substituting something for nothing. So here in this case, we say, look, whatever base was on the front of a ridge, just drop it, and then we've used it up. That's how we've done the substitution. So we're returning what's left. We've advanced our cursor one element. Now, we have to account for this case. Coq requires our functions to be total. Like, okay, maybe it was empty. Okay, that's weird. Something's like gone wrong. But like, we can handle it. Just say, like, okay, look, you said substitute B. All right, I get it. But we actually ran out of our original strand. So we're just going to pretend that we're like the add edit, right? Like, just let it ride, right? Like, just, we still have no original strand. Pretend like we were add. Okay. Now let's look at delete. Delete says, okay, I'm in my original strand. I've got some base in front of me, and I just want to ignore it. Skip it. So first off, if we're deleting, we have nothing to add to the output strand. We'll return none. Okay, and now we have to do that same skip logic. This looks exactly like the match we saw below. This is the good case, right? This is the case that we expect to be in. Like, delete should only happen when you're actually somewhere where there is a base. But maybe you're at the very end and there's nothing to delete, right? You've hit the elbow, right? There's nothing left there. Okay, fine. Weird. That's not supposed to happen, but we can do something that I think will be right. Like, this should be okay. Just return the empty list. Okay, last one. Let's look at copy, and then we'll do some examples, which hopefully will clarify everything. What does copy say? Copy says, well, look, you're somewhere in the strand. Whatever base I have here, could you copy that one over? Okay, and that case happens here. If you had some base, then we'll just say, great, sum B. Whatever base we got in our original strand, let's copy that one over. And then whatever's left of the original strand, whatever came after, well, that's what's left of the original strand. This is implementing the copy logic. But again, we have to handle this degenerate case where, like, we've run out. Like, we're at the end of the string, we're at the end of the strand, and yeah, there's nothing to copy. Like, okay, that's weird. It's like kind of too bad. But like, well, whatever. Look, we're not gonna make up a base to write on. That seems like a bad idea. Making stuff up is just like not a good policy. That's not for adults. And then, well, is there anything left of the strand? Well, no. We'll just pretend we're still at the end, right? We'll just let that ride. Okay, let's do some examples, sort of inspired by these guys. So let's work on DNA source and just see what a couple of different edits do. Okay, so copy for DNA source. Now let's check our understanding. The thing here should be the base we're going to write onto the target strand, and then this will be what's left of our original strand. And that seems right. Copy should say, well, we'll copy over the G, and then we have cat left. Okay, let's check. Apply, edit, delete DNA source. Okay, that makes some sense. We don't want anything to be written to the target strand. We're just deleting something from our source strand. And then what's left of it? Well, here's what's left of it. Let's add the base C. Okay, we'll copy C over, well, excuse me, not copy. We'll write C over to the target strand, the output strand. And then our DNA source is still there, right? Because add doesn't sort of affect, we're not going to move our cursor at all. We're just going to say, yep, I'm still at GCat, but I've written a C to the output strand. Now, if we change that and we write a different one, call it A, then that'll be the thing that we write. But no matter what, orig will stay the same. Okay, let's do the last one. Compute, apply, edit. Substitute C, why not? Well, T, mix it up. So we'll substitute says, well, great, we need to write a T. And then now the G that was on the front of DNA source, that's gone. It's been substituted for T. What if we write an A? A cat. We found it. Really been enjoying getting to see cats on y'all's videos in class. Really leavens it for me. One last thing I want to remark on. What if you substitute G? Okay, interesting. So that'll say write a G over, and then we'll have consumed the G. Now, that's a little funny, right? This substituting of the G, isn't that exactly what we saw over here? Right? Isn't that the same edit? Huh. That's interesting, right? These are two edits, two different edits, substitute G and copy are clearly different edits, that give us the same behavior in this function. And then if you think back to the cost video, we assigned them different costs. Isn't that funny? Okay, we'll get to think about this a little more and a little harder in a bit. Hopefully this has given you a feel for how this function works. If you don't get it, I'd recommend do a couple more examples, make up a strand of your own, compare a bunch of different edits, maybe play around with the empty list, see how that behaves. You can figure out how it behaves, you could read it off the function, but maybe running some computes on your own will be helpful. In the next video, I'm going to show how we use this apply edit function to build up something that can run a list of edits, and we'll be able to sort of start to come up with edits that actually do the transformations that we care about. Okay, hopefully this was clear. Questions on Zulip as usual. Talk to y'all soon.